Good afternoon everyone, I am Mohan, Assistant Professor, Department of Mechanical Engineering. So today we are going to discuss about the CATIA V5 softwares. Okay, so CATIA V5 coming under the CAD softwares. Already we know about the CAD. CAD is nothing but it's a design and modification and another implementation by using the computers. Okay, so in this one of the major software is CATIA. So we have more number of softwares that are available in design. Okay, like this CATIA and ProE. SolidWorks, okay, like that we are having a number of softwares. Majorly we are going to discuss on the CATIA V5. Okay, so CATIA is abbreviation of computer aided three-dimensional interactive application. Okay, this CATIA software is developed by the Dassault system. They are the one of the leading aviation industry. Okay, they are manufacturing fighter jets and other aircraft. Okay, it's based on the one of the European industry. Right, this CATIA incorporated with three kind of systems. Okay, first one CAD CAE, CAD CAE and CAM. Okay, it's incorporated this three type of applications. Okay, first already we know that what is CAD. CAD is also known as it's sketching and drafting and modeling software. And another is CAE is nothing but computer aided engineering. This we can done some analysis work. Analysis means structural analysis, and structural analysis means if you are taking the solid rod, okay, if you are applying the load, we can calculate the stress at any point on the entire rod, or shear stress distribution, strain values, and change of length, change of dimensions. Everything we can analyze by using the CAE software. And another one is thermal analysis. Thermal analysis means so we can analyze the heat transfer rate. So if you are taking the boilers and any other kind of heating equipment, we can analyze the heat transfer rate. And also next one is flow analysis. Flow analysis also we can do by using the CAE software. Flow means we can use the if you are considering a pipe, okay, we are transferring the water from one place to another place. Okay, so in this there's a friction will be in the pipe surface. So due to that, some stress value is created on the surface of the pipe. Okay, that stress values also we can calculate by using the software. And another one is the last one, kinematic analysis. Kinematic linkages, what's the stress included in the linkages points, like that we can analyze by using the CAE softwares. Okay, so the example for CAE software is nowadays majorly using ANSYS, Silumia, like that. There are the simulation softwares are available. And next one is CAM. CAM is nothing but computer aided manufacturing. Okay, so once we are doing the design work, and we can import the file to CAM softwares. Okay, CAM softwares, they can create the manufacturing programs, part programs, okay, by using the G code and M code. Okay, so already G code and M code, a large number of codes are available. So by using the G code and M code, it will produce the it will produce the programs. Then it can able to simulate in this program itself. Then we can transfer this program to the CNC machines. CNC machines, in reality, it will produce the same kind of command what we have designed in the CAD by using the CAD software. Okay, so previously we have used the CATIA V4 version. Okay, so the Dassault system initially they developed the V4 version only for using the surface modeling. Okay, so previously only after optimizing this another three parameters, we can able to do the all kind of works. Okay, and it's useful the graphical user interface and parametric technology and flexible and design reuse and knowledgeable design also we can provide. Okay, so what's the major difference between CATIA V5 and V6? Nowadays in the market, these two softwares are available. Okay, first one is CATIA V5 and second one is CATIA V6. CATIA V5, as I already told you, is an updation of the CATIA V4 version. So by adding this CAD and CAE and CAM provisions in this CATIA V4, and they developed the CATIA V5 versions. And we can also do the this. We can also do the simulation work by using the Silumia, and the manufacturing CAM work by using the Delmia softwares. Okay, both are developed by the Dassault system, and also the Enovia support also is there. That's also developed by the Dassault system. Okay, so CATIA V6 is nothing but that's what are the features available in the CATIA V5? The same thing available in the CATIA V6 itself. In addition to that, so we are having the product data management and also product lifecycle management. Okay, it's purely based on the PLM based modules. Okay, so PLM is nothing but, so we can monitor the entire lifespan of the one component or part like that. Okay, from initial idea to that component goes to the scrap level. Okay, so that the entire thing we can monitor by using the product lifecycle management system, and this Enovia is purely based on the PLM based software, and this Enovia is now incorporated with the CATIA V6. Okay, so Enovia and CATIA V6 is fully useful for the entire business of entire industry. Okay, so they can control from the component design and everything, and also the inventory control and the stock, everything we can manage by using the Enovia one, that now that's incorporated with the CATIA V6. So as I said, it's a CATIA V5. It's a flexible modeling environment. Okay, so we can share the data for any other kind of softwares. Okay, so if you want to do the analysis in the ANSYS software, so we can share this file to ANSYS. Okay, and same thing, knowledge editable. Okay, so we are using the design constraints, and also we can use the non-geometric and geometrical design information. Okay, and the third one is okay, so master model. Okay, so you can assemble all kind of 3D components. Okay, so features of CATIA. Okay, so it's based on this 5 kind of things. Okay, features based modeling. First one is feature based modeling. That's nothing but, so already predefined geometric parameters are available. Okay, that's in terms of icons like whole circle. Okay, slots. Everything is available in the based on the icon. So we can easily use that features. And the second one is parametric. Parametric is nothing but parameter based modeling. Okay, so parameter based modeling in this based on the value. Okay, value will define the behavior and characteristics of the component. Okay, so if you are changing the one value, that will change throughout the component parameters and properties. Okay, if you are changing the increase the diameter, so definitely it will affect on the final assembly and also the result on this other systems. Okay, next one is constraint. Constraint will ensure the shape and exact position of the component, or position of the drawings. Okay, sketches in the exact positions. There's a number of constraints are there, so we will discuss on the next slide. So fully associatable means in the final assembly, if you are changing the one parameter, okay, that will automatically changes with the other assembled components. Okay, if you are assembling 4 or 5 components, if you are changing one dimension, that will associate with the other component. Next one, parent-child relationship. Okay, so where you are going for assembly work. Okay, so one component is assembled with another one, so both will like parent-child relationship. So changes will go through the entire assembly. So where we are using this CATIA, so for mainly used aerospace industry and automobile, consumer goods and shipbuilding and machineries we are using for designing purpose. Okay, so they are the users of the CATIA. Okay, so mainly India's we are using the Mahindra and Tata Motors, and nowadays they are using TVS also. They are using the CATIA, TVS and Royal Enfield industry. They are using this software. Okay, these are some example for the Cat A design products. Okay, so these are the Cat A modules available in this workbench. Okay, so mostly we are having 138 modules are available in the market, but basically we are using this kind of modules. Okay, for basic license they will only provide this kind of modules. So if you want another additional module, we have to pay separately for the license. Okay, in this mechanical design, shape design and analysis simulation. As I told you, mechanical design we can produce the part component, and the shape design we can use for sheet metal design work, and analysis and simulation, as I already told you, we can do the analysis work, and architecture, engineering and construction of plant. So in this we can design the entire plant, including the machinery, the location of the machinery. Okay, like that, where the persons are moving from, where the raw materials are handling, like that we can design by using the ACE and machining and DM digital markup and equipment and system, machining simulation and ergonomics design also we can do by using this Cat A module. So in this Cat A module, as I told you, first one is mechanical design. Mechanical design, we are having this kind of workbenches are available. First one, sketcher, part design, assembly design, drafting, generative sheet metal design, and wireframe and surface modeling. We will discuss one by one. Okay. Steps involved in CAD design. So as I told you, creating the base sketch. First of all, we are creating the 2D base sketch. Then we are converting into 3-dimensional object. Okay, 3-dimensional by using the base feature and adding some dress-up features. Dress-up features means we are adding the some holes, some smooth by creating the smooth surfaces. That are all the dress-up features, and the assembly function operation, and the last generating manufacturing drawing. Okay. So this is the Cat A user interface. So if you open the Cat A software, so our window will be like this. Okay. So these are the standard toolbars are available. First, this is the start. The other regular toolbar will be there, and here the file toolbar, save and cut, like this kind of tools are available. Then here pan, zoom in, zoom out on the actual position, so rendering, this kind of view toolbars are available here. Then the application toolbar. This application toolbar, if you are changing the workbench to the other one, so this application toolbar will going to changing. Okay, so this window in the assembly workbench. Here we can how you can identify it's our assembly workbench means here. Here this place is showing that this is the manipulation tree or specification tree. This place is showing that the product one. So if it is coming as a product, that's called as the assembly. Okay. So already we know that we are using the bike and car, everything. Okay. So car is the assembled product. For this the final product. So that's sold for customers. Okay. So in this a number of sub assemblies are there. Okay. In this engine one of the sub assembly, gearbox and clutch plates. These are the additional sub assemblies there. In this additional sub assemblies, there's a number of parts will be there. If you are considering the engine, there's a crankshaft, piston, and connecting rod, rings. Everything is crankcase. Everything is the one of the each part. Okay. So if you are seeing this the product, that's called as a sub assembly. You can add a number of products inside beyond this. It's a product. It's a final product. Product 1, product 2. That will called as a sub assemblies. Okay. So after that, if you are you can add the number of parts. Okay. So you can add the individual number of parts you can add in this. Okay. So you no need to add anything. So if you are opening with this Cat A window, so automatically this that will add with the one by one. Okay. So as we discussed earlier, so same toolbars are available here. So it's a fly. So this is a view toolbar. We can discuss one by one. It's a fly through. Okay. So fly through means if you are moving the cursor from one side to another side means, so where you are moving the cursor, that place will be getting zoom in. Then second one is fit view. Fit view means if you are enlarging the view, if you are giving the fit view, that's fitted to the component fitted to the screen. And the layer control, so we can go for one by one layer. So we can use the cut portions and this pan option. So if you are moving, you can move any kind of places in the windows. And the rotate option, zoom in, zoom option, you can zoom in, zoom out. And the normal view, okay, normal view means so where you are starting the work component, so that view will be available in the normal view. And the standard view means this the front view of the component. Okay, you can change the n number of views, front view, top view, side view. You can change by using this by picking the down arrow. You can, if you are picking this down arrow, there will be a number of options will be displayed for front view, top view, side view, like that. And standard views means okay, this is the standard view. And the so next one is shaded, hidden lines and wireframe and user defined icons are available. Okay, if you are picking this, so this icon will be displayed in this bottom. Next one is this one, hide and show. Okay, if you are adding the two components, okay, you can hide any one component and also you can swap this another one. Next one is property. Okay, you can see this property of the component. Okay, so if you are already giving any kind of property like material weight and everything, you can see by using this property icon. So next one is mouse usage of the so you can same do by using this mouse usage, pan, rotate and zoom in, zoom out option by using the mouse usage. And next one is compass. Okay, compass also used to rotate your component at any places. Okay, by using the place, this is called horizontal plane, vertical plane, like that it will be there. So you can rotate by using this compass. If you are picking this top portion, you can rotate at anywhere. Okay, your component also get rotating from any kind of angles. Next one is specification tree. As I already told you in this print, here part body, pad. So what tools we are using, that will be displayed on the specification tree. Okay, so if you open the product, so here it will mention the product. So after this, it will show the part sub assemblies, like that. Okay, you can rename this. If you here it shows the part body, so you can rename the component name, part name. So first one is sketcher module. For sketcher module, so if you normally open the assembly window, so there will be icon as like this. Okay, entering into the sketch, or else you can go to start mechanical design and sketcher. It's a sketcher module, and you can, this is the icon to exit from the sketcher. Okay, exit from sketcher. Next one, geometry creation. This is the important tools for create the geometry. Okay, this is the continuous profile. It's a profile toolbar. This is the continuous profile. You can the same time you can create a straight line and the curved one, and the circle, anything you can create continuously. Next one is a rectangle. If you are picking the down arrow, it will show the number of options to create the rectangle. Next one, circle. So here also there is a number of circle option will be there. So if this option will be, you can pick the center point, and if you are picking the another place, that will produce the circle. You can change the radius or diameter of the circle, and sometimes you need to sometimes you don't know the radius of the circle. So only if you are having two lines like this. Okay, so if you are picking the center point, okay, this will be as a center point. If you are picking this line as the second one, so it will take as this as a radius, this distance as a radius. It will create the circle. Okay, like that a number of options is available. Next one is splines. Okay, you can create the curved sketches. And next one, ellipse. Next one, straight line. Then center line. Center line means this is used to indicate the whole center. Okay, if hollow surfaces are available, okay, you can use if you want to mention the center line of the hollow surface, so you can use this center line. And the next one, point. Okay, this is a single point. If you are picking the down arrow, so you can create the multiple points. Multiple points option also is available. Next one, geometry operations. Is profiles. It's the next one is geometry operations. If you already create the sketches, you can modify by using this software Okay, if you are creating the rectangle, if you want to remove the corner as a smooth surface means you can create the corner on the radius, and the chamfer you can create the chamfer. It's a trim option. If you are having continuous line, you can break the line by using this break option. Next one is mirror option. So if you already drawn the sketch like critical sketches, or if you are drawn the critical sketches, okay, you can't able to draw again. Okay, so you can do the mirror option. You can create the number of sketches, and also the project 3D element. Okay, if you are this project 3D elements used to only if you are having solid objects. Okay, solid part modeling is available. You can project any of the edges like that. Next one is constraint. So constraint, next slide we will discuss one by one. So next one is toolbar. So toolbar is a snap point. Okay, snap point means already you know the grid one. Okay, grid means like our graph sheet like that. Okay, each grid point will be 10 into 10 mm. Okay, so x-axis 10 mm, y-axis 10 mm. So if you enable this snap to point, okay, it will move each 10 mm point. So that's called as a snap to point. And next one is construction geometry. Okay, so if you are drawing the complicated surface, if you don't sometimes you need to draw the reference line. Okay, by using that reference line only you can go for you can further proceed the continuous sketches. That time you if you don't know the reference line, you can use this option to make it as a reference line. While you are converted to part modeling, that one consider that reference line. Okay. Next two also is the constraints. Okay, it's a linear constraint. It's a parallel. So where you are using this constraint option, same thing is available here itself. Here you have to enter manually a number of details. Okay, so as I already do, this is the constraint toolbar. Okay, constraint. If you open the constraint one, so it's a constraint dialog box. There's a number of options are available: distance, length, angle, radius, semi-major axis, minor axis, and symmetry, midpoint, and equidistance point, fixed coincidence. Okay, will discuss one by one. Okay, here you can see few of options are disabled one, and few of options are enabled one. Why this is happened means here the screen itself they draw only the straight line. They drawn only the straight line. The straight line option only is enabled. Okay, so if you only draw the circle means then only the radius diameter will be enabled. Otherwise this will be in the disabled position. Okay, so for this the straight line you can give the distance and as well as the reference line from the coordinate point and also the angle. Okay, so you don't need to draw in the horizontal manner. You can draw in the any kind of angles. Okay, that's angle constraint also you can provide, and at any time we won't use the fixed constraint for critical cases and the some Boolean operations. If you have done the Boolean operations, that time only we will use this fixed constraint. Otherwise we won't use the fixed constraint one. And the coincidence means if you are having the two lines, okay, this two should be joined a continuous one. That time you can select this edge point and this edge point. If you are giving the coincidence, the both will join in the same position. So you can make it as a continuous line. And the parallelism, okay, parallelism is you can draw the parallel line. Okay, so if you normally draw the parallel lines, it will not be a parallel. Okay, you need to give the parallelism constraint, then only it will be parallel. You can't move in the any other kind of angle. You can move separately one line. Next one, perpendicularity. Perpendicularity already you know that. Okay, so you can draw the perpendicular line. So you can give the angle to the perpendicularity. It will be in the 90 degree of angle, and the horizontality and verticality. Okay, so this normally it will be in the coordinate point. So we can split this constraint as a three elements. Okay, if you are having one element, you can use fixed, horizontal, and vertical only. Okay, so if you are using this two elements like this two element, I am using this circle and the line also is there. You can use these kind of constraint options. And if you are using the three elements, you can use the symmetry and the equidistant point. Okay, so horizontal, vertical already you know that. The coincidence also you know. The next one is concentricity. Next one, concentricity. Okay, so that's nothing but if you are having the two circles like this, so this is the center point of this smaller circle, this might be the center point of the larger circle. Okay, so sometimes you need this two center points should be in the same place. Okay, so if you are giving this selecting the two center points, you can give the concentricity option, it will join together. Automatically it will go to this position, largest diameter center point position. Next one, tangency. Tangency already I have already given the diagram. Okay, if you are having circle and the line also is there. Okay, if you have circle and the edge point. Okay, if you are having tangency, okay, it will come to the line makes the tangency for the circle. Next one, parallelism. Okay, parallelism, you can make the two line as a parallel line. Then midpoint. Okay, so you can identify the midpoint of the line. Then perpendicular, I already told you this. You can draw the perpendicular line. Okay. Next one, if you are having three elements. Okay. Next one, symmetry. Symmetry means if I have the three vertical lines means each line will have the different gap will be there. Okay, so I need to have the equal gap means you can give the symmetry. Symmetry means it will make the equal distance between the three lines. And the last one, equidistant point. Okay, so you can identify the 2 points. So if you are moving the 1 point means the another point also will come together. So this is the example for 2D sketches. Okay, here 2D sketches, some of the lines are in the green, some of the lines are in the white color. Why the difference means it is in the under constraint. Okay, so next we will go to how the constraints are displayed. Okay, so if everything in the green line means then only it will be in the iso constraint or fully constrained. It will every sketches in the green means then only you can go for creating the 3D sketch, 3D design. There's a constraint diagnosis available. So there's a number of colors are there. So first one, white color specify the under constraint. Under constraint means that line is not gone for the constraint option. Okay, brown color means non-changed elements. Non-changed element means you can't change the that parameter of the particular geometry. Next one, green is fixed element or iso constraint element. Okay, so we will not use the fixed constraint. So you have to go for iso constraint option. Okay, so green will display the iso constraint option. The purple color is over constraint element. Red color is inconsistent element. Inconsistent element. So when you are converting from 2D sketches to 3D part design, that time only this red color will be indicated. Okay, some error will be there, so it will observe the error that will make in the entire geometry in the red color. So that time you need to identify the error and you have to rectify that. So next one, so creating the partition from the sketches. If you already create the sketches, you can go for exit from the sketcher module. Then there's an icon is there. Okay, like it's named as a pad. If you are getting the pad option, the dialog box will be displayed like this. Okay, so you can give the dimension like the linear dimension or diameter or length, any kind of dimension you can change it here, and you can specify the value and give, if you want to give the reverse option. Okay, so if you want to give the extrude from the x direction means normally it will be in the same direction. So if you want to do the opposite direction means you can give the reverse option. Okay, so you can go to, if you are give the apply means it will create the 3D model like this. Okay. So this is the example for your 3D part modeling. The last one is assembly design. Assembly design, there's a number of tools are available. This is mainly we are using this this one. So this is the insert existing component. Okay, why? Because we are using the means. So we are always making the part design and we are saving save in this system. So we can choose from our directory, we can import this existing component, and we can import the n number of components, and we can assemble together. So for assembly purpose, we can use the move toolbar. Okay, so move toolbar, we can have three tools: manipulate, snap, and explode and assembly. Okay, so manipulate means we can rotate at any angle. Okay, and the same thing, it's like same like the pan, zoom in, zoom out option. Okay, rotate any kind of angles, and span means you can move at anywhere. Explode and assembly means, okay, so if you assemble, then if your constraint is not given means, if you are giving the explode, okay, so then after that you will give the update option. Okay, so that time it will not go to the original position, okay, where you are assembled. Okay, so this is the constraint toolbar for used for the assembly purpose. Okay, this is the example for your assembly, machine wise assembly. Okay. So this is the example for your drafting. Okay, after making the assembly, okay, you can go for drafting workbench. You can input the drawing. Okay, you can make the any required construction models. Okay, construction drawings. Okay, you can cut at anywhere. You can make the detailed drawing for manufacturing. So these drawings only will be delivered to the manufacturing team. Thank you.